Hey everyone, today we are going to talk about process graph and forking. Before we start this example, it is really important that you understand short circuiting so you can understand what I'm going to talk about later. First, if you can do it on your own, if you could fill out the right part, that'd be awesome. I'll give you like a hot second to do it, and I'll just write the answers. Okay, 1 and 0 is 0, 1 and 1 is 1, 0 and 0 is 0, 1 or 0 is 1, 1 or 1 is 1, 0 or 0 is 1. Cool. This is important and this is important. And this here, it's the same as, so if our A is 0, then we don't care about B, because if B is 0 or 1, we'll still get 0 as our final answer because of A. For OR, if A is 1, then we don't care about B. So here in those two examples, we will get 1 as our final answer. Doesn't matter if B is 0 or 1. If you could just remember that for the AND, that for A, if A is 0, then we don't care about B. And for the OR, if A is 1, we don't care about B. Okay, so now that I just explained short circuiting, we can get going with the example. So on the left is the problem we're going to go through. I have said that the first fork is F1, the second fork is F2, and etc. So that way you'll understand the process graph better if you haven't really seen a process graph before. If you don't know what a parent or a child or a process is, I highly recommend you read chapter 8, especially 8.4 and 8.5. That will also help you with your shell lab. Okay, so we're going to take care of F1 first. So we're forking, hence we are returning the parent and the child. Child is 0, the parent is 1. Cool. This is pretty normal. But now we need to remember that when A is 0, we don't care about B. So this means that we only care about this side right now. We don't care about the right side. So for F2, which is the second fork, we are only going to fork this one. So I'm just going to repeat this really fast. This is A where A is 1, and this is A where A is 0. We don't care about B, which means we're not forking this side. We're only forking the left side. Okay, now we're taking care of F3, so we're going to fork again. This time, for F3 to happen, we need both A and B to be true. So that means we need A to be 1 and B to be 1. So here we have B is equal to 1, and here we have B equal to 0. So that means we're only forking on the left side. Okay, so this was F3. So we are basically done with half of this problem already, but it's about to get much harder. So this was the AND part. Okay, now for the OR, I'm going to change color, and I'm going to be using blue for F4. Okay, so F4 is just like F1, so we're just going to fork basically everything. Okay, so we just finished doing F4. So now we're going to go on and do F5. So if we remember what we talked about in short circuiting, if when A is 1, we don't care about B. We're not gonna look on the left side where it's 1, we're only gonna look at the right side where it's 0. Because once again, when A is 1, we don't care about B. So that means we don't care about this side. We only care when A is 0, because then B could be either 1 or 0. Okay, so we're going to do F5, and we're going to fork where it's 0. from now on, I'm not going to write P and C because you guys got it that on the left side it's P and the right side is C. Okay, we just finished F5. So now we're going to do F6. In F6, we are in the scenario where A was equal to 0 and where B is equal to 1. And that equals 1, which is true, which F6 can only be, we can only fork if we're in a true situation. So we are going to fork everywhere that is a 1. Awesome. So now if we were to count the number of black circle we have 16 circles. However, there's one more thing we need to do is we need to printf hello world. So I am going to represent that printf hello world in this color. And this is going to apply to everything, to every process. So this means we have this many hello worlds. 1, 2. We have 20 hello world. Hence, this entire example will print 20 hello world. Okay, I'm going to have a really quick recap. If you have understood this video, you don't need to listen to the rest of the video, but just for those who want a really like fast, quick recap. So we used this here to figure out what to do and what not to do. Basically for the and, we only forked where we cared, and we did not fork where we didn't care. Where once again, when A was 0, we didn't care. This here was when A was 0. Hence, we only forked on the left side. And then we did a similar logic with the OR. And hopefully the colors can help you differentiate each different part. If you have any question, please feel free to come to my office hour or comment below any question, email me, and good luck.